Ready to start?
Okay, great.
All right, so I will go ahead and kick things off. Good afternoon, everyone. This is Courtney at ISPE, and welcome to this month's First Friday webinar. Just a couple reminders before we get started. You all received about 20 minutes ago a link to the handouts and to the quiz. And we ask that you please complete that by Sunday night. If anyone has any questions, please feel free to contact me after the webinar. Certificates will go out to everybody about 1 week after today. And I will go ahead and introduce our presenter. This month we are pleased to welcome Mark Golden, the Executive Director of NSPE. And with that, I'll go ahead and turn things over to Mark.
Thank you, Courtney, and good afternoon, everyone. This issue of autonomous vehicles is one that has been a center of focus for NSPE at the national level, and I'm delighted to have this opportunity to give you some context and history, update a little bit of where the development of autonomous vehicles is going, and in particular why we feel as licensed professional engineers it's a topic which should be of concern. So, I'm assuming most of you know who NSPE is, so I won't spend a lot of time talking about who we are and what we do. There is on our website, nspe.org, a section called Who We Are and What We Do. If you're unfamiliar with us and we pique your interest and you want to get a little more deeply into things. But basically, and in context, NSPE is the society of PEs, by PEs, and for PEs. In partnership with 53 state and territorial societies, we operate as an integrated network at the national, state, local levels, and for more than 80 years have been serving as the recognized and authoritative expert in licensure, ethics, and professional practice. Illinois Society of Professional Engineers, of course, is our state partner in Illinois. Nationally, NSPE has more than 31,000 members representing PEs in all disciplines. Our vision or approach to the PE license and our role in protecting and serving those who hold the license, the public who depends upon it, is that recognition that being a licensed professional means a whole lot more than just having technical competence and holding a permission slip like a driver's license, which says you're allowed to do certain things. Core to that PE license is the commitment to hold the public health, safety, and welfare above all other considerations, and it is that commitment and focus and role that NSPE exists to serve for all disciplines and practice areas, focusing on those things all engineers hold in common. And again, that role of defining, promoting, protecting the PE license, not only for the interests of our members, but for the public that you serve as PEs. So why talk about autonomous vehicles? We view it as really the first major emergent form of artificial intelligence being deployed commercially in any significant way. There obviously are pieces of AI built into a lot of different technologies, but this really represents the first full-scale society-wide impact. And it's going to have ramifications that go far beyond transportation. Fully proven autonomous vehicle technology offers the potential to significantly enhance the quality of life in the United States. For the general public, in terms of promised improvements in traffic safety, reduction of accidents, reduction of harm to individuals and damage to property. But even more significantly, I think, in helping to eliminate barriers to full participation in society by persons who currently do not have access to vehicles, particularly individuals with disabilities and the elderly. It will give them the freedom and autonomy that they don't currently enjoy to more fully participate in society. It's new, it's big, it's shiny, it's exciting in that sense, but it really comes at the end of a long tradition. The history of transportation in America has always been one of transformation. Increasing the speed, comfort, and safety of the ability to get from point A to point B has been part and parcel of the nation's development from its founding. In the late 18th century, overland transportation was by horse, while water and river transportation was primarily by sailing vessel. Population was centered on the coasts, and inland travel was difficult and dangerous and limited. Economic expansion in the late 18th century and early 19th century spurred the building of canals to speed goods to market, of which the most prominently successful example was the Erie Canal. And that rapid expansion of railroads brought the canal boom to a sudden end, providing a even faster, better, more regular year-round mode of transportation that quickly spread to interconnect all of the states by the mid-19th century. During the industrialization of the United States after the Civil War, railroads led by the Transcontinental Railroad system expanded quickly to serve industries and connect the growing number of cities. Then something even more transformative happened, which was the invention of the automobile. The advent of the automobile signaled, if not the end, but the beginning of the decline of railroads as the predominant form of transportation, and introduced for the first time autonomous direct control by individuals of a mode of transportation that was feasible even over relatively long distance. Didn't end with the car, of course. 1903, the first flight at Kitty Hawk, and within a decade, in 1914, a 25-year-old test pilot by the name of Tony Janis flew this aircraft, designed by Thomas Benauset, made out of wood and muslin, the so-called Flying Boat Number 43, across Tampa Bay. Journey only lasted 23 minutes. The significant thing, non-technical there, was it had a paying passenger, Abram Fell, the mayor of St. Petersburg, who paid $400, won at auction for to be the first paid customer in flight. If you look forward now to things like SpaceX and commercial space travel, you will certainly see the analogy. Then, of course, that airline transportation, air transportation did not stop. It's continued to expand for recreational, leisure, business, personal purpose, extending into the emergent commercial space travel. Why this thumbnail sketch of the history of developing transportation? Because I think it needs to be juxtaposed against a area of development which is not viewed as directly related to transportation. If you dial back to the early 20th century, obviously industry and government did not set out intentionally to build unsafe buildings or bridges, unsafe dams or water systems or gas systems. But in some instances, the need for such basic infrastructure and the pressure to meet the demand for these services developed far more rapidly than the necessary evaluations related to public safety could be performed. So failures with tragic consequences were the result. We could probably do an entire seminar on some of these great engineering failures, but among the most notable was the St. Francis Dam. That's a curved concrete gravity dam built to create the largest regulating and storage reservoir for the city of Los Angeles, California. March 12, 1928, that dam catastrophically failed. The resulting flood took the lives of nearly 500 people. The collapse of the dam was considered to be one of the worst civil engineering disasters of the 20th century and remains the second greatest loss of life through such an accident in California's history. Another example, the New London School explosion in March of 1937 when a gas leak caused an explosion destroying the New London School in New London, Texas, a community in Rusk County, previously known as London. The disaster killed nearly 300 students and teachers, making it the deadliest school disaster to this date in American history. Events such as these set the backdrop for the creation of licensure laws, which now exist in all 50 states and the territories. So fast forwarding today, this view of the need for responsible development and innovation juxtaposes what John Kaag, an ethicist writing in the Chronicle of Higher Education, has highlighted, which is the engineer's responsibility to be aware of the society he or she is creating. With the increasing and exponential rate of change in various emerging technologies, and frankly the concern, and in some cases outright fear, that those new technologies face, many are asking the question of what is the role of the engineer, specifically the licensed engineer, in these technologies. And we start from a very simple premise, that the same commitment to both technical competence and ethical accountability that went into designing and building the physical highway transportation system needs to be applied to the emerging field of autonomous vehicles. So there's the Google test car. It is not accidental that it looks kind of cute and cuddly. That was the design, meant to make it appear less threatening. But it sets up this discussion, which the first thing we have to get into is that when you start talking about autonomous vehicles, you will find as many different definitions and a lot of statements which are thrown out as blanket statements which apply across the board, really only apply in a very specific sense. So let me sort of very quickly lay sort of the groundwork of how the view of autonomous vehicles is being defined. The National Highway Transportation and Safety Administration, in a rulemaking that goes back several years, tried to create a taxonomy for autonomous vehicles, separating them into 5 levels, numbered 0 through 4. Level 0 being a car with basically entirely everything under the operator's control, no automation, no significant automation. Level 1 represents existing automotive technology already incorporated in recently produced cars, or when you get to level 2, optionally available on newer, higher-end vehicles. These are things like the automatic braking, self-parking, those sorts of features, which are increasingly very common in automobiles at an increasingly low price point. Level 3 is driver optional methodologies. That is cars such as the Tesla car now in limited test deployment, which operates what it calls autopilot mode. There still remains an operator in the vehicle, but the operator can elect to transfer control to the equivalent of autopilot on an airplane. And then we have fully autonomous level 4, which is the ultimate design. That is, the fully autonomous vehicle could conceivably be operated without a driver or operator of any kind. Buses which would depart and drive from point A to point B, cars which could be summoned by an individual consumer, appear at their location, pick them up, and drive them where they intend to go. Now that's a real neat taxonomy, but what has actually proved to be the case as these technologies being developed is that Google and other automakers discovered that once you get past level 2, once you get past those features that are already being introduced in the car and begin looking at going to level 3, consumers stop paying attention. That level 3 where you could envision it's the car with a driver with some autonomy features just gets skipped over entirely. And all of the major autonomous vehicle development is really either operator-controlled cars with some nifty intelligent features, or the El Dorado they're aiming to conquer, which would be a fully autonomous, driverless car. The other important distinction to keep in mind is that there are really 2 entirely distinct categories of technology which are being looked at and developed in order to achieve that fully autonomous vehicle. One is vehicle-to-vehicle communications, such as the Google car, where it is sending information, detecting information about its environment and communicating with other vehicles in order to interact with each other and avoid possible collisions, for example. And vehicle-to-infrastructure communications, so-called smart highway implementations where sensors in the car are communicating with the road system, and the road system is providing the traffic control and direction activities. Something that is significant about both of these approaches is that there is already some pressure and limitations on the available radio spectrum. So there's 75 megahertz of spectrum in the 5.9 gigahertz band, which is being used for intelligent transportation system and vehicle safety and mobility applications. But even there is not agreement on how to ensure the high capacity usage which is anticipated in order to avoid interference, for example. Or like your Wi-Fi, this is a bad analogy, but when the Wi-Fi gets full at Starbucks and your computers begin to slow down, that is an issue which would be of significant concern if it's governing automobiles trying to avoid collision or some hazard. The other thing to keep in mind as you look at the industry is that there are players who are forced into partnership who operate under two completely unrelated paradigms. So in the effort to develop autonomous vehicles, it's like having Russian speakers and English speakers trying to work together. It is that different an approach. First off, there is the old school automakers. They bring a fairly top-down approach to manufacture and regulation of their products, heavy focus on establishing rules and standards, with those rules and standards being controlled in a central and, if it's not too redundant, standardized fashion. They are partnering often with new entrants like Google and Apple, who take a very decentralized, bottom-up approach, work things out as you go, don't constrict development by adopting too overly regulatory a posture. The automakers tend to have limited or no experience designing and operating large open software platforms, which are anticipated to be used simultaneously by a large number of unconnected and uncoordinated users. The software companies have never built anything as complicated as an automobile, let alone a transportation system, road system. Most of the Google, Apple software-driven developments in this area is not at all interested in the intelligent network in the highway approach. They're really viewing this is their hardware operated under their control. One of the interesting things, I don't want to overstate this, but you will see it evident in some of the cockiness, if you want to call it that. Others have called it arrogance of companies like Google who have been involved in this. It's the established paradigm for software companies of that sort. If you think about what they need to do with their applications and products when Microsoft releases a new version of Windows, for example, is to beta test to profitability. Load your app, test it till it crashes, and then fix it and test it again until you get to a sustainable, reliable enough version to operate under the new operating system. Obviously that load it until it crashes approach is not particularly attractive when you're talking about developing vehicles which will be on the road with individual drivers and non-autonomous vehicles. Autonomous vehicles and intelligent road systems, whatever the approach, regardless of who's developing them, are areas of innovation that require attention now while the technology is still emergent. And it is our view that that attention should come from people not only with technical expertise, but also the ethical and safety accountabilities that licensed professional engineers have typically brought to the projects under their purview. We have been concerned, and I'll talk a little bit later, about the rather balkanized approach to the regulation and deployment and operation even of autonomous vehicles. And we believe it's that rather disjointed development is not in either the public's interests or the manufacturers, who need certainty and consistency in order to create public confidence and build their markets. So what are some of the concerns which we have raised? Currently, industry, that is, those who are experimenting with cars and software, are dictating the message, focusing on the anticipated benefits of autonomous cars. The reality is that autonomous vehicles will operate as part of a larger transportation system that has many elements and complexities. The overall transportation system requires a significant amount of travel, not only on public roadways, but private roadways, toll roads, private drives, parking lots, intermodal facilities, ferries, parking garages, and the like. In fact, most journeys will begin and end on non-public roadways, and often will include intermediate segments that will take the vehicle off public roadways. So the focus of autonomous vehicle developers on the ability of their cars to operate safely and consistently in a public highway situation really doesn't begin to cover what the cars will be required to do, particularly before full autonomy. According to Wikipedia, and I think their figures are probably about as good as anybody's, which is not always the case, there are just under 4 million miles of roads in the United States, of which only 2.6 million miles are paved. Additionally, autonomous vehicles are going to have to share the road with many types of vehicles which are hardly standardized. You know from your own driving experience that the amount of distance, the follow distance, for example, that you can safely maintain, the type of awareness that you need to maintain will differ widely if you're following a private vehicle pulling a boat, a large rig carrying freight of some sort, and a motorcycle. If you happen to be the operator of that motorcycle, the entire range of issues you need to be sensitive to, not only from other vehicles on the road, but in terms of road conditions. There are hazards which are not significant to an automobile, which are significant hazards to a motorcyclist. So autonomous vehicles are going to have to operate in a way which recognizes that diversity of need. It's also a dynamic environment. Autonomous vehicles need to be able to address how both autonomous and non-autonomous vehicles will handle situations they encounter together on the road and allow for a 360-degree perspective. In one meeting with industry that I participated in earlier this fall, I had an extremely smart engineer from a highly reputable automobile manufacturer state right out, as long as our car, our autonomous car, can avoid running into anything, what is going on behind the car will take care of itself, as their argument or justification that there was no need for sensors to detect what was going on behind the vehicle. That exhibits a fundamental lack of appreciation of the realities of the roadway today. Patrick Lin, director of the Ethics and Emerging Sciences Group at Cal Polytech in San Luis Obispo, noted that light detection and ranging LiDAR-based machine vision systems used on autonomous cars simply see numerical values related to brightness of each pixel and then infer what the object might be. we take our sight and ability to distinguish between objects for granted, but that is still a very difficult thing for a computer to recognize what the object is, even if it recognizes that it is an object at all. There's been a lot of discussion recently of the first fatality in an automobile under operating, not under operator control, but under systems control, where there's a lot of debate about the cause of the accident. Was the autopilot being used inappropriately and driving too fast? But basically, what it came down to was the sensors could not detect the difference between the sky and a white truck, causing the vehicle to drive underneath a big rig, fatally killing the driver. Reliability and dependability of sensor elements are obviously a major concern. They must be able to function in all types of driving conditions at all times of the day. I'm sure you read, many of you read, far less tragic, but the issue where a Google autonomous vehicle merged into a bus. And this is a classic example of negotiation that's part of normal driving. We're all trying to predict each other's movement. The car obviously needs some work. As I pointed out, and I think a lot of the autonomous vehicle system promoters and developers fail to fully appreciate, a lot of transportation takes place off public roadways. A lot of the autonomous vehicle developments depend heavily upon roadway markings that are critical to their functioning, their AV technology functioning appropriately. There was a recent press notice where the the CEO of Volvo's North American operations, Lex Kersmakers, complained to Los Angeles Mayor Eric Garcetti that the test of their car had failed because the road markings in Los Angeles were too faded for the system to recognize it. I would just observe, if autonomous vehicles are struggling to find lane markings in America's second most populated city, they are going to have a really hard time finding lane markings on the thousands of miles of poorly paved roads elsewhere across America. Even in our urban centers and surrounding suburbs, faded or non-existent markings are commonplace. So until the technology has advanced beyond the point where typical and ordinary conditions can be handled, it's going to be tough. In short, real life is a lot messier than the design laboratory. The weather, the ability to follow a planned route, and a myriad of other circumstances can and do change quickly and without notice when you're on the roadways. Accordingly, autonomous vehicles need real-time functions for driving in all weather conditions and for both daytime and nighttime driving, and in particular, processes and responses that can adapt to driving conditions that change during operation. And just count on the vehicle regularly discovering it has to operate outside of its approved operating conditions. Many questions remain about particularly in the debate on the approach between smart highway-controlled autonomous cars or vehicle-controlled autonomous car sensors. There is going to be significant improvements to the nation's basic infrastructure to accommodate full realization of autonomous vehicle potential. Again, pavement markings, as I just talked about, and just keeping the roads clear and well marked. That's not an issue that has been discussed extensively by the proponents of the AV vehicles and will need to be addressed. This is before you get to the new infrastructure costs, such as the sensor systems that may be required as part of an intelligent, smart highway system. Security is an increasing risk. I don't know if any of you have been following. There's the DEF CON convention going on in Las Vegas this week. That is the largest convention of good guy, if you will, software hackers who get together to see what it is, how easy or hard it is to hack systems in order to help build defenses against hacking. And the issue of the security of autonomous vehicles has come up. You know that a technology has hackable potential when it starts showing up. I have seen at least 3 popular television shows where, as a critical plot element, somebody has seized control of someone else's car by hacking the computer system on the car while it's in motion. The fear for malicious actors taking control of glaring flaws in smart car security is on the rise, and it really needs to be considered before the deployment of such vehicles increases to a significant level. A group last year of Virginia-based researchers funded by the Department of Defense found that it was relatively easy to remotely hack into a driverless car's control system, and that hardening against such attack can be inexpensive. But that's not what people are focusing on now, and we think focusing on that level of security is going to be very important. The other issue when we get to fully autonomous cars is the potential for this technology to be weaponized. If you can imagine a car bomb scenario which suddenly does not require the participation of a suicide bomber willing to go with the vehicle, there are significant concerns that I think are not deal breakers, but need to be focused on sooner rather than later. This is a non-technology issue, but it is a significant one. It is the issue of liability. The pat answer you get when you talk to federal regulators, state regulators, autonomous vehicle developers, and many who have approached the issue of autonomous vehicles from a legal perspective is that it's really very, very simple. In an automobile accident where harm or damage to property is caused, that is a personal liability issue. It's caused by, you need to determine which driver was at fault, and they can be held accountable. In an autonomous vehicle system, it's really very simple. It just becomes a product liability issue. If an autonomous vehicle fails to perform as it is supposed to and something bad happens, then the manufacturer, of course, is liable for it. I think what is missing from that gross oversimplification is the likelihood for huge discussions and debate and controversy to be undertaken as to whether that was in fact a result of product failure, and I imagine there are going to be a great push to try and segregate those issues out and say there was some failure of the operator to maintain the vehicle properly will be used in order to escape liability, and there will be a significant increase of multiple parties, each claiming the other is responsible when an accident recurs and liability needs to be assigned. And there's the issue of privacy, big data. If you imagine how the concerns or thinking that has gone into how much information is currently collected based on our movements with smartphones in our pockets. Automakers already collect and store location and driving data from millions of cars on the road today. That will increase with self-driving cars, and privacy advocates have begun to express some concern that the data collection will grow more intrusive. The more sensitive the data, the more lucrative it might be for a company like Google, according to John Simpson, who is an advocate for the California-based consumer watchdog. According to a report issued by the GAO, the Government Accountability Office, last year, It found there were not adequate protections in place over the data which is already being collected in automated computer systems. And in the wake of that report, AAA, the largest motorist organization in the United States, called for companies to adopt a consumer bill of rights that set stricter privacy standards. In the hands of a company like Google, which earns the majority of its revenue from advertising and sells its advertising based on individual personal data collected, I think this is not a specious concern. But all of this gets to really what I think is the largest, broadest area of concern for NSPE as an organization and engineers as members of society, which are the ethical implications of autonomous vehicle. There is a giant task in front of the industry, according to Patrick Lin, who I spoke of earlier from California Polytech University. It's not at all clear who decides the rules that will govern how vehicles interact, autonomous vehicles interact with each other, or how they interact with non-autonomous vehicles on the roadways. There is a classic ethics case study or model, which many of you, if you take a basic philosophy course, may have been exposed to in your undergraduate years. It's the so-called trolley car scenario, which asks if a trolley car is traveling down a set of tracks at a high rate of speed, and the only option the trolley car operator has is to switch to the track to the left or switch the track to the right. There is no opportunity to stop. And the choice is to drive into a brick wall or to drive into and the scenario varies. They can really juice it up and say, drive into a crowd of children or nuns or some other helpless and attractive members of the community. But basically the decision is, if you have a choice of protecting yourself from harm or protecting others from harm or large numbers of others from harm, what is the proper decision to be made? And that is the kind of decision which autonomous cars, even semi-autonomous cars where there's still an operator in the car, are and will be forced to make in split-second timing. There's been some research into this, and there are two, I think, really significant and mutually exclusive findings. They don't surprise me, but they I think, capture the dilemma of the ethics concerns surrounding autonomous vehicles. 76% of the public answered that they thought it was better to sacrifice one passenger rather than 10 pedestrians if a decision needs to be made on accident or collision avoidance. 76% recognized it would be immoral for one passenger to place their interests above the health and safety of 10 pedestrians. However, 81% of the same people polled said that if they were to have an autonomous vehicle, they would place first priority on the vehicle protecting them and their family at all costs. So, it becomes, if you are looking at an autonomous vehicle barreling down the road, everyone finds it very simple to say the needs of the many supersedes the needs of the few. But if you're talking about putting your family or colleagues into an autonomous vehicle, the feeling becomes the prime objective will be to protect ourselves. How safe is safe? There is, I should say, we try to eliminate from consideration the extremes on both ends of the spectrum. There are some who think that autonomous vehicles and artificial intelligence are part of a vast trilateral commission atheistic conspiracy to destroy society and human life as we know it on this planet. There are those on the other side who have a entirely Pollyanna-ish view and say there's absolutely nothing to be concerned about. Isaac Asimov's 3 laws of robotics, the first being that a robot will never do anything to harm a human being, can be counted upon and depended upon, and there's no need to be worried about any of this. Even if you eliminate those extremes from consideration, there is still a wide range of legitimate concerns expressed about how safe do you need to be and how do you balance safety against experimentation, innovation, and deployment. One of the things I have encountered in my work at both the state and federal level talking about this issue with regulators is that there is, from the manufacturer's perspective, a far higher degree of transparency necessary from them. Recent tragedies and actual obfuscations from automobile manufacturers, such as regarding the GM ignition switch problems, Takata airbags, and the VW emissions scandal, in which systems were designed to specifically thwart legitimate regulatory requirements within the car, make it understandable that a large part of the public is skeptical and distrusting of what automakers are saying. And I actually had a VW engineer who was standing in line to testify at one of these hearings, who basically at the height of when that story was still just rolling out about the emissions scandal, the company position was essentially, you don't need to worry about regulation. We, the manufacturers, know better than anyone else about what will work and how to work on the public, and you can just trust us. And I think that's probably not a reasonable posture to maintain. So we at NSPE have been advocating for an open, transparent, and collaborative involvement at the federal, state, and local level involving regulators, industry, and the public. And that is, in fact, not only the morally correct approach to take, but that it will, in fact, speed the economic performance and speed of deployment for manufacturers in this area. Such transparency and consistency is necessary to not only increase public awareness and understanding, but lead to acceptance of the new technology, and that will in turn speed deployment. Another area of non-technology involvement which needs to be of concern is human behavior and driver expectancy. It will be necessary to educate consumers, drivers, about how these features work. Tesla, in some of its deployment of its autopilot feature, auto driver feature, found that owners act in ways Tesla had never intended. They intended this to be a sort of just a cruise control on steroids kind of thing, where a driver could relax and some of their attention, but would still remain alert and attentive to the vehicle and its motions. And they were greatly embarrassed to find videotape on YouTube that showed up on the web of a owner setting the auto driver feature and climbing into the back seat while his Model S kept driving. People are going to do stupid things and use the technology in ways other than they were designed to, and that is just a feature of system development. Limitations in safety features may not be intuitive or obvious. People are going to have to learn how to use this technology before it can really take off. There is a considerable amount of discussion, particularly in California, which has adopted the approach that it will not allow fully autonomous vehicles at this time, but is interested in advancing the deployment of autonomous vehicles with an operator in the car. And one of the critical aspects of that paradigm or regulatory approach is that the car will return control to the operator if it's ever in a situation where it does not know what the best choice is, or if driving conditions change. If, for example, a car is designed to operate autonomously only in daylight hours, it will actually go through a safe system shutdown if it gets dark and require an operator to resume control of the car. The challenge is it's not really those, in most situations, the need to return control to the operator is not something that can take minutes or even tens of seconds. It often requires a split-second decision. So even if the auto driver mode recognizes there is a collision it is unable to avoid and that the driver needs to assume control, if that driver is sleeping or watching a video or reading, how long will it take them to effectively re-engage with the automobile? Google has talked about developing what it calls the big red button, which will allow, visually it's a big red button on the dashboard that the operator can hit, which will automatically disengage all of the autonomous vehicle features. But even Google has admitted that that can't happen instantaneously. There are some systems which will take some time to disengage. So that sort of lays out some of the issues and features which are engaged. In the sort of brief amount of time left, let me talk a little bit about what we're doing and how we're approaching this. In December of this past year, the topic of autonomous vehicles went full throttle first in California, where, as I mentioned, they're one of the leading states in all things AV, and they released a long-awaited set of draft regulations which were to serve as a template, hopefully, for other states and the federal government. NSPE very quickly became active in the stakeholder discussions with volunteer and staff leadership, speaking with California DMV and raising some of our concerns and issues which we hoped would be addressed. And it all happened very fast. Within a month, I was able to participate in a conference of AV experts and stakeholders in Washington, D.C., involving all of the automobile manufacturers, and flew to Los Angeles the following week to testify at the first of two stakeholder meetings in California. Our California State affiliate CEO Marty Kramer attended the second meeting in Sacramento, and much of the paper and resulting draft regulations that have begun to emerge showed that we had had some impact with that input. Within weeks of that California announcement in December, Nevada became the second leading state on the issue, also announcing new regulations in a very rapid development process. And we were able, NSPE was able to provide input directly to the top decision makers within those agencies and send two members of our Nevada State Society to attend a summit in Las Vegas on the future of mobility. Nevada approaching it far more from an intelligent highway system approach, California from an autonomous vehicle, intelligent vehicle approach. We have been and continue to track and monitor legislation in regulatory proposals in the area of autonomous vehicles, and there are proceedings at some stage in 40 states. In Illinois right now, HB 3136 creates a requirement for a study and report to be issued. That's fairly typical of where many of the states are. The legislation provides the Secretary of State will, in Illinois, should conduct a study on the feasibility of the operations of autonomous vehicles in Illinois and produce a report on its finding. And the legislation requires the Secretary to submit the report and recommendations to the Governor and the General Assembly. It passed the House and has gone on to the Senate, where it remains pending at this point in time. We believe it may come up when the Illinois Senate reconvenes in November. National Highway Transportation and Safety Administration has also issued proposed, at least suggested proposed rulemaking. They are taking a far more, frankly, hands-off approach, I think, than we would be entirely comfortable with, wanting to bring consistency to what is developed by the states, but make the primary regulatory developments rely upon the states to produce those. As I mentioned, I was able to testify at a hearing before the National Highway Transportation and Safety Administration earlier this year and lay out much of what I've described to you on this webinar today. The AV proponents are very, very aggressive and active. I will say one of the things that there is a coalition that is trying to push for the rapid deployment of autonomous vehicles with little or no regulatory oversight. It is a coalition which is being organized by the automobile manufacturers, and their head lobbyist happens to be a former chairman of the National Highway Transportation and Safety Board. So there is political heat at play. I should say, even having said that, I have been impressed and commend the seriousness of the commitment to safety that manufacturers and developers have demonstrated. I think they are really trying to do the right thing. However, a century of experience demonstrates that protecting public safety is best done when there is someone in the decision chain who does not face pressures from stakeholders, shareholders, or non-technical management to meet budget, project timelines, or sales projections. Public safety is best served when there's someone in the decision chain who has a duty that overrides competitive pressures to be the first to market or surpass other manufacturers' offerings, someone who has a clear and enforceable duty that overrides even peer pressure to be a team player and not be the guy or the department or the group within the corporation who raises safety concerns that might delay a high-stakes project. In short, we think there ought to be licensed professional engineers involved in the development and deployment of this technology. We believe PEs ought to be made part of independent third-party testing of vehicles prior to their deployment on public roads, and that since such testing regimes would fall within the practice of engineering under state licensure regulations, they should be performed under the supervision of licensed PEs. Let me more specifically where the PE would fit in. We believe that the internal testing processes conducted by manufacturers ought to be conducted under the responsible charge of a PE, whether employed by the manufacturer directly or an independent consulting engineer or engineering firm retained by the manufacturer. And then in addition, there needs to be independent third-party testing of vehicles performed once before they're introduced into the public roadways, again under the responsible charge of PE, and that should not be the same PE who did the internal testing for manufacturers. NSPE nationally has developed a position statement 1772, which was approved by the board at its May 2016 meeting, which lays out some of this. I mentioned the NHTSA activities. They are ongoing. They are delayed. We keep hearing that they were going to have drafts out by May, and now it's, or excuse me, by the end of June. Now the end of July. Now all they're saying is by the end of summer, and I'm not sure what that means in the context of it being now early August. We'll see where things go. Before I open it up for questions, I want to thank you for showing the interest to pay attention, to become involved in this. If you would like more information on the development of, particularly the regulatory developments in the area of autonomous vehicles, if you go to the NSPE website, on the left-hand side there is an option for more information labeled Issues and Advocacy. That will take you to a page where if you click on Action on Issues, there is a whole section on autonomous vehicles. I know Illinois is a state where dual membership in state and national is not required. I hope if any of you have not exercised the option of being a national member, you will consider doing so. We view the ability to influence society and protect the license as something that is neither a state nor a national responsibility, but can be most effectively addressed by all the piece parts working together. To strain an automotive analogy, if you are depending on these functions being performed, that the role of the engineer being promoted and protected, and the role of the license being, the credibility of the license being preserved. If you're depending upon just your state or just a national. It's like driving a car with only two wheels. You're missing half the gate. So I would urge you to consider that. We have about 5 minutes left, and Courtney, I would be happy to take any questions.
Okay, I actually haven't received any yet, so guys, if you have questions, go ahead and submit those. Mark, I would just like to say on behalf of ISPE, thank you very much for taking the time to present on this very interesting and very touristic, I suppose, topic today.
Yeah. Yeah, and it's, I think this is one of those that has captured public attention. This is one of those areas of engineering that if you engage with neighbors and friends and community who are not part of the engineering field, you'll find them talking about it a lot. So, and everyone has an opinion, most of which they are extremely willing to share. I do think it's important, and I don't want to sound like a conspiracy theorist, because I do believe this technology has great promise and ought to be encouraged and supported in every way possible, as long as it is done in an ethical and responsible fashion. However, there is a lot of work going on to try and sort of soften the market for autonomous vehicles. I don't know if any of you use the free Wi-Fi service provided by your local Starbucks, which is tends to be provided by Google, that there was an article on artificial intelligence essentially saying there's absolutely no need to be worried about anything. Just trust us, and we will all be fine, which ended up in the headline feed in Starbucks for about the last 90 days, and doesn't seem to be. It's now a very dated article, but it still seems to be there every time I go to Starbucks. So this is a mainstream issue.
Absolutely. Well, it doesn't look like any questions are going to come in. So with that, I will go ahead and end just a couple of minutes early. Mark, thank you again, and thank you everyone for calling in and attending today.
It's my pleasure.
Hope you all have a very nice weekend, and we'll talk to you next month. Bye-bye.
Thank you much. Goodbye.